Okay, if you can hear me, then if you're able to hear me, please say say yes in the chat. If you're able to hear me, please say yes in the chat. If you're able to hear me, if you can hear what I'm saying, please say yes in the chat so I know if everything is good in terms of the audio. What we want to do is I want to go through everything. I want to go through all of the tutorials for EMAT. And yes, just make sure that we are good at differentiation, the whole of differentiation. And please remember your duty as well, for everybody who's watching here. Remember, your duty is to subscribe. Your duty is to not only subscribe to my YouTube channel, is to enroll for my tuition, okay? Enroll in my tuition and have me help you with your engineering, maths, and all these other engineering modules. So this is not, what should I say? This is not free service, whatever. Just make sure you remember that it's very important for you to support the cause, for me to be able to keep helping you. In here, I'm going to take you through everything. Hopefully, it will expose you to what you get. For those who haven't enrolled, it will expose you to what you will get if you enroll. This is very, very important for me, and I need everybody who is watching now to know clearly that it is very vital and important for you to enroll and support what I'm doing for you guys. So here is our tutorial 5. We're going to go through the things that probably look hard. I want to make sure you're good at differentiation. It is not a topic that you it is not a topic that you fear. It's not a topic that should beat you in any way. You should get the maximum marks from any differentiation question. So I'm going to start with this tutorial 5 because I feel like it is the most feared one. And it's a little bit different. So if we are good at this one, it is going to help us to then be good at the rest. There is a lot to do, and there's a lot of things that we're going to be working on. Just to start by doing the questions for nth derivative and Leibniz theorem and mean value theorem. So we want to do these ones. And when we can do these ones, the rest is just walk in the park. So we'll enjoy anything else. Let's go through this. Let's talk about the nth derivative, okay? We start with the idea of nth derivative and we want to answer the questions that are given below. So here is the idea of nth derivative, and if there is anything else to add, I'll add it later. But the first thing is that when you're dealing with the nth derivative, right, we want to master nth derivative, Leibniz, and then the mean value theorem, see what it is that these questions want you to do. Now, if you remember in high school, you did something called nth term, right? In high school, you did something called nth term. When they would ask you to say, please find the nth term, for you to know that you have gotten the answer correct, you needed to have something like this. Tn is equal to an plus 5 or whatever, or 7n. Some could have 6 minus 5n or something like that. But it was always a formula. Nth term, for you to know you have found the nth term, it is a formula which we can use to find any missing term. And it's the same thing for nth derivative. It is a formula. Nth derivative is a formula. If you have found the nth derivative, it means you have found the formula which you can use to find maybe the 10th derivative or the 11th derivative or the 5th derivative or the 6th derivative or the 19th derivative or the 100th derivative, any derivative. You can find any derivative by having a formula. So when we are asked to find the nth derivative, they are asking us to generate a formula which we can use to find any derivative, the first, the second, the third, the 15th, the 100th derivative of something. That is where you start. So let's start with that. When you're dealing with nth derivative, maybe let me tell you right now, here is the concept, is that when you're dealing with nth derivative, you are going to meet 5 cases, but for you, for your math and for the situations which I've seen, it's 4 that come. They don't bring the last one. Let's put the cases for nth derivative that you're going to meet. You're going to meet case 1, a situation where you have y being equal to e to the x. Okay, sometimes you can be told that you have y being equal to, I want to do e to the ax, in case you have something. You have y being equal to e to the ax or ae to the x, anything like that. Okay, you have this. I have y being equal to e to the ax. Now I want to be able to find, this is my case one. These are the cases you're going to find. You're going to find 5 cases. Maybe let me say case 2. Let me put them next to each other. You have 4 cases that you are going to meet. Case 2, and then case 3, and then we will have our case 4 for nth derivative. Let's put it. So here we have now our case 4. For our case 2, so this is case 1, case 2, case 3, and case 4. For our case 2, you are going to have a logarithmic function. So you're going to have, this is an exponential function, then you're going to have a logarithmic function to say y is equal to ln of, we can say inside here, ax plus b. Okay, that's like the maybe more complicated version, if I should say. Then you're going to have another one, which is now the trig version. You now have your y being equal to sine of ax plus b. It could be sine just ax. Sometimes b is not there. Then, so here is the trig equal to ax plus b to the power of -1. That's the one which you're going to meet for your, it could be to any power, but the one which you're going to be meeting for your work is to the power -1. Here are the cases which we can have, the 4 cases, which you are going to need to know the nth derivative of. For the trig, so here it's for trig to say, how do I find the formula? Hello? When we say you want to find the nth derivative, we want to see what will the formula look like? How do I then generate the nth derivative? This is going to be for what? This is your algebraic, eh? Then in here, it's your logarithmic, eh? You have your logarithmic, and it doesn't have to be ln. It can just be any log, eh? Log of ax, whatever. Log. If we just say log, it is going to be log base 10, right? Of x plus b. We have all these. And for our trig, you have I, where they sine. You can also have where it is y is cos of ax plus b. We're going to see it a little bit later. So let's see, how do we get the nth derivative for each of these? It's easy for you to remember the formula or cram the formula, but let's quickly see how we're going to get the nth derivative. So this is the beginning of nth derivatives. This is the beginning of your work. You have 4 types of functions that you must know how we generate their formulas, how we are going to generate the nth derivative. It's a formula. And it will be saying, for if in differentiation, in the topic we are doing right now of nth derivative, the first derivative is called y1. So if we see us say y1, this is the first derivative. If you see us say y2, this is the second derivative. If you see us say y3, this is the third derivative. So derivatives are, you have your y1, your y2, your y3. So I want to find yn, a formula for the nth derivative, which I can use to find any. I want to be able to find the 16th, the 10th, the 7th, the whatever derivative you want. So how do you generate this nth derivative thing? You are going to generate it by differentiating 3 times or 4 times, eh? Commonly 4 times, 3 times or 4 times. Then you see the pattern. Then you're going to see the pattern, and you're going to use the pattern to generate a formula, and you're done. That's the nth derivative. Come on. If you differentiate, then you see the pattern. The pattern is what is going to help you generate a formula. So for here, we differentiate the first time. Okay, so for you to know how to do these derivatives, let's just put something which all of you must put the moment you're going to walk into your test. The moment anybody walks into their test, eh? This is taking me to something which I had skipped, which I didn't want to do first, but I just am forced to do it first. We're coming back to this idea of nth derivative real quick. What you must know is, and I won't do too much, or maybe let me not do too much. You must just know, I'm coming to show you the whole table. You're going to put it the moment you enter the test. I'm coming back to show you. But what you must know is that when you differentiate in our table, we say that if you differentiate e to the x, you are going to get e to the x. Then in our table, we also say that if you differentiate ln x, okay, if you differentiate ln x, you get 1 over x. Or if you differentiate log x, if you differentiate log x, you are still going to get 1 over x. Okay, talk about it to say what will be the log. So here we want to focus especially on ln x to say if you're going to differentiate an ln x or some log base 10 of x, you're going to get 1 over x. This is the derivative of this, right? Then you should know also that the derivative of sine x is equal to cos x. Then you must also know that the derivative of cos x is equal to negative sine x. Here are derivatives you're going to need to know for this section, which you're about to do, this nth derivative section. Put these derivatives here. We should just know these derivatives. We're going to do the entire table. Now let's go ahead and let's do for this one, these 3 or 4 cases that we gotta know how to differentiate and find the nth derivative. Let's see how we are going to do it. How are we going to find the nth derivative for this? Wait, give me a sec. All right, sorry for the glitch. Look, guys, what I was saying was, if you're going to get, let's differentiate this. If we're going to differentiate this 1, 2, 3 times, then we're going to see what is happening, and we're going to just make a formula. Don't make it hard. As long as it's that we're not doing it right, it's not supposed to be hard. Let's differentiate. So here you can see that if you differentiate an exponential, it comes back as it is. So here, that's what we are going to know here. You're differentiating this. So when you get y1, it will come back as it is, e to the ax, because it's an exponential function. But because the power is no longer just x, the power is something which is not x. I won't go to explain that. I'm going back to explain that a little bit later, what is happening here. But you then multiply by the derivative of that. So you multiply by the derivative of ax. The derivative of 2x is 2, 3x is 3. Derivative of ax is going to multiply by that. So you can say that your y1 is e to the ax. This is going to be your y1. Then your y2 will be, what will be my y2? I differentiate y1. So a stays outside. A stays outside. Then I differentiate e to the ax. I've already seen that it is a e to the ax. Okay, this e to the ax, I've already seen its derivative. So this is going to be a squared e to the ax. Then we can go to the third derivative now. Third derivative, we know that we are differentiating in this second derivative. So it's going to be what? It's going to be a squared multiplying the derivative of e to the ax. It is a e to the ax, which is going to give us what? A cubed e to the ax. This is your y3. So we have this. We can see the pattern. We can be able to say what is happening to yn. What is the nth derivative? We can see that the first derivative was a e to the ax. The second derivative was a squared e to the ax. The third derivative was a cubed e to the ax. So the nth derivative is a to the n, then e to the ax. The third was a cubed. The fourth will be a to the 4 e to the ax. So it's kind of like that. So here we can already see our yn. It'll be a to the n e to the ax. This is how you're going to get your nth derivative if they give you y being equal to e to the ax. This is how you're going to get your nth derivative. Let's get the nth derivative for logarithmic, okay? I like to do logarithmic last. Maybe let's start with this trig. How am I going to get the nth derivative for this trig thing? How am I going to get the nth derivative? Can you all hear me? Hello? If you can hear me, type yes in the chat, please. So just to make sure. If you can hear me, then please put yes in the chat. If you're able to hear me, please put yes in the chat so I know if you're able to hear me. Type yes in the chat, people, if you can hear me nicely. Okay, now we are going to get the nth derivative of the other thing. Let's find, I can't see anyone typing yes in the chat. Please type yes in the chat if you can hear me. Okay, so what was I saying? I was saying that when you're now doing for trig, you want to find the nth derivative for trig. You want to find the nth derivative for trig? Let me share with some of this link. Just differentiate 3 times and then you're going to have, so nth derivative is not even a problem. So we're going to say y1. What is it? I differentiate sine. And this has taught me that when you differentiate sine, you're going to get cos. So here, since you're differentiating sine ax plus b, you get cos of the same thing, ax plus b. And since it's not an x, you're going to multiply by the derivative of that inside. What is the derivative of ax plus b? Derivative of ax is a, derivative of b is nothing. So we can say our y1 is a cos of ax plus b. Then we can go and get our y2. Y2 will be, we are now differentiating y1. We are differentiating y1. We keep a outside. Then we're going to say, what's the derivative of cos? Negative sine of ax plus b times the derivative is negative a squared sine of ax plus b. Then we are going to have y3 now. What is it going to be? The third derivative. What are we going to do to get the third derivative? We are going to, come on, stay awake, push, guys. For the third derivative, what we are going to do is differentiate this one. So we bring, it's a constant, they don't go anywhere. When constants are multiplying, when you differentiate or integrate, if there is a constant multiplying, it will never go anywhere. So this negative a squared ain't going nowhere. Then now we are differentiating here. You differentiate sine, you're going to get cos of what? Of ax plus b. Now since it's not an x, you then multiply by the derivative of the inside. Derivative of ax plus b is just an a, because the derivative of ax is a. The derivative of b is 0, because it's a b that's adding. It's not one that's multiplying. So this one will go. Here what I'll now have is cos of ax plus b. This is going to be my third derivative. And I'm kind of saying what is going on. What you then do is to find the fourth derivative. And this is what you're going to do as well if your y was a cos. Here we have our y being a sine ax plus b. If y was a cos x plus b, you would still differentiate like what I've done. You will differentiate like what I've done. Now what you're going to do is you're going to get the fourth derivative. Remember, just differentiate. If you want to find the nth derivative, differentiate and analyze what is going on. So here you're going to say negative a cubed stays outside. Then we differentiate this. The derivative of course is negative sine of what? Of ax plus b times the derivative of the inside. The derivative of ax is a, b is nada. So this now becomes a to the 4, because the negative and the negative will cancel. A cubed and a will be a to the 4. Then it will be sine of ax plus b. That's your fourth derivative. Now, this is already helping me see something. What you are seeing, number one, is that when you differentiate the fourth time, you will be back where you started. The fourth derivative has given me a to the 4, but it has given me sine of ax plus b, which is the same as what I started with, sine of ax plus b. So that means that if you differentiate sine, you are going to get cos. If you differentiate cos, you get negative sine. If you differentiate negative sine, you're going to get negative cos. If you differentiate negative cos, you're going to get positive sine of x. This is all of x. X. And you can see that you differentiated 4 times. number 1, number 2, number 3, number 4. 4 times. When we differentiated 4 times, we went back where we started. So now we are back at sine. So when I differentiate 4 times, I have gone through a complete revolution. I am back where I started. And a complete revolution is 2 pi. So that means when I differentiate 4 times, I have gone through 2 pi. So that means every derivative is going to be a pi over 2 shift, pi over 2 shift, over 2 shift. So now if I want to find a formula. I want to find a formula for this derivative of sine ax plus b. But I can see that in the first derivative it will be some cos. In the second derivative, that's the first derivative. In the second derivative it will be some sine. In the third some cos. In the fourth some sine. So here I'll ask you, in the nth derivative, are we going to put cos or are we going to put sine? In the nth derivative, you are going to put the same as the one you started with. But remember to include the phase difference to show that every time you differentiate, it will actually change by pi over 2. In other words, if it was sine, it will become cos. If it was cos, then the next stage it will become negative sine. Then from negative sine to negative cos. Then from negative cos back to sine. So here we are showing that. And how we are going to include it is we are going to put a pi over 2. Because each derivative changes it shifts it by pi over 2. So if I'm now getting yn, it is going to be equal to, we said it is equal to, we said you're going to say sine of ax plus b, right? But what you know, because the original one was a sine of ax plus b, that original one. So the nth derivative will also have a sine, but it won't be just ax plus b, to be ax plus b plus n times pi over 2. This gives me pi over going to be the angle I change in every time I differentiate. My angle is going to move by pi over 2. Okay, my angle is going to move by pi over 2, yes. And remember, for any time that I differentiate. So if you have differentiated 7 times, you must come and say 7 times pi over 2 to have the amount it will change by. Okay, then you're going to find the 7th derivative, whatever. Then, last thing to look at is the power outside. You're going to see that when I was finding the 4th derivative, I had an a to the 4 outside. So if I'm finding the nth derivative, it will be an a to the n, then you have this whole thing. What is this? This is going to be the nth derivative of trig things. So you don't put a bracket though. It is just a to the n, then sine ax plus b plus n pi over 2. Are we together? This gives me the nth derivative of any sine or cos. So if it was sine, then you're going to put sine. If it's for cos, you're going to put cos. Right. Next thing is going to be case 3 and case 4. We want to find a derivative. So anytime you get a trig, don't tell me you can't find the nth derivative. No, it's just an a to the n, then it comes back. But remember to put this phase difference, the angle it changes by anytime you differentiate. Here's another nth derivative formula. For trig we can do, for cos x or sin x we can do. Then now we are doing y is log of a over log of ax plus b, and y is ax plus b to the negative 1. Let's find the nth derivative. We are still getting it by what? Differentiating. Then we look for the pattern. Now let's differentiate. What is going to happen when I differentiate log? I'll get 1 over. So my y1 will be equal to 1 over ax plus b. Okay? Then you are going to multiply by the derivative of the inside. Derivative of ax plus b key a. So you can now say your y1 is a over ax plus b. Isn't it? Then now you're going to say y2 will be here you have a over. This is going to be the second derivative. We differentiate. So what you're going to see is, how do I differentiate when I have a over something like this? I want to differentiate to get y2, so let me rewrite my y prime. Now, here y1 is just a number, a, over ax plus b. So what we're going to do, we will change the x plus b. It is in the denominator, right? Give me a sec. Yes, we continue. Now we are saying that I have my first derivative. Look, you can't keep this as a fraction. This is just a number. So we can't. Here we have this whole thing to the power of 1. If I take it up, it will be this whole thing is now to the power of negative 1. So it becomes ax plus b all to the power of negative 1. Because this was just a number. A is just a number. So that is why I won't put a fraction when I just have a. A is a number. Now what I'm going to do is I'm going to, when I have it like this, differentiate to get the second derivative. Because now I can, and I'm sorry, there's something I'm going to be doing here which is called the chain rule, which how I wish I say I started with that part, because that's the most important part. That's the most important part. The chain rule is going to help. That's the most important part of differentiation, but it is what it is. This is a chain rule question, okay? And if you're not good at it, just wait and for the second part where I'm going to go through all that and answer differentiation questions. In here, I'm strictly doing nth derivative and Leibniz, so kind of like that, which is also differentiation. So you gotta know differentiation, but in case you just don't, in case I haven't done with you, then wait for me to cover that part. It will help you do this even better. But here you should be able to do this. Remember, it's just differentiating. There's nothing complicated. You differentiate first, second, third, fourth. Then you look for the what is going on. Then you can write down the formula. You have the nth derivative. Okay, and you must be able to apply it in questions that have something which is not just a sign of ax plus b. It'll be a sign of something, sine 2x, sine whatever. We just differentiate. Then we see what will be happening and we get our nth derivative. So nth derivative, differentiate, Captain. Differentiate 1, 2, 3, 4 times. See what's going on. Then make a formula. That's the nth derivative. Okay? So you're going to do, let's differentiate the second time to get y2. I drop that negative 1. It becomes negative a. Then we have ax plus b is now to the negative 2. Remember, you drop the power, then reduce it by 1. So we drop this power, which is negative 1, and then we reduce it by 1. Then we multiply by the derivative of the inside, because this is not an x. So we have to multiply by the derivative of the inside. Derivative of ax plus b is just an a. So basically, we have our y2 being negative a, then it is ax plus b to the negative 2. Are we done? No. Can I get y3? Yes. Let me get y3 now. It is going to be, you drop down this negative, it becomes 2a squared. Then what do you have? Ax plus b to the negative 3. Okay, we've dropped the power and reduced it by 1. Then we multiply by the derivative of the inside by a, which is the derivative of the inside. You have y3 being equal to 2a cubed multiplying ax plus b to the power negative 3. Then we can now get y4. Y4 is drop the power again. Negative 3 times 2, that's negative 6. Multiplying ax plus b to the negative 4. Then you multiply by the derivative of the inside. You multiply by the derivative of the inside. Derivative of ax is what? Is a. It's like the derivative of 2x is 2. The derivative of 4x is 4. So the derivative of ax is a. So you now say y4 will be negative 6a to the 4. Then you now have ax plus b to the negative 4. Right. Now let's analyze our derivatives and see if we have a trend that we can see. Here is my y1. Here is my y2, the final one. Here is my y3. And then here is my y4. How do I get yn? What is it equal to? Now let's see. y1 is a multiplying ax plus b to the negative 1. y2 is negative a squared multiplying ax plus b to the negative 2. Oh, y3 is 2a squared, okay, times a. y3 is 2a cubed, rather, multiplying ax plus b to the negative 3. Okay, y4 is negative 6a. So what you're going to see is that here, positive, y2, negative, y3, positive, y4, negative. So if your signs are alternating like that, that means you're going to have in your nth derivative, you're going to have a negative 1. A negative 1 is how you are going to be dealing with that. Sign changes. The changes of signs, you deal with negative 1. Now this negative 1 might be to the power of n minus 1, or this negative 1 might be to the power of n. Now how you decide that is by looking at the, here, it's by looking at the second term. If the second term is negative, then it will be negative 1 to the power of n. Is the power of n minus 1, right? If the second term is negative, because I'm just putting in my mind, yes, if the second term is negative, then it is to the power n minus 1, because the second term is negative. If the second term is positive, then your negative 1 is to the power of n. Guys, we are developing a formula here. And I said, if the signs are alternating when you come from one to the next. One is negative, the next one is positive, the next one is negative, the next one is positive, the next one is negative, the next one is positive, the next one is negative. That means in your nth derivative formula, there is going to be a minus 1. And this minus 1 is either going to be to the power of n minus 1, or it will be to the power of n. Okay, now you're going to go confirm to say, you have seen that there is going to be a negative 1. But now you need to confirm, is it to the power of n minus 1, or is it to the power of n? How do you know? You look at the second derivative. If it's negative, then it is to the power of n minus 1. If it is positive, then negative 1 is to the power of n. So here, y2, you can see that it is negative. So that means our power is n minus 1 for negative 1. So negative, we have done it. But then the next thing you're going to see is that the fourth derivative goes on with the power of a. So if I want the fourth derivative, it will be a to the 4 as well. So that means if I want the nth derivative, it will be a to the n. Then here I have ax plus b is now going to be to the, here, negative 4 when I am at 4. So it is going to be, when you're at 4, it's negative 4. It will be what? To the negative n. So here we have to the negative of n. Then what are we going to put? The last thing you're going to put is whenever you see a number, y3 being 2, y4 being 6, the only time you come from 2 to 6 is when you are doing factorials. Factorials, if I say what is 2 factorial, it means what is 2 times 1 times, 2 times 1. 3 factorial, 3 times 2 times 1. 4 factorial, 4 times 2 times 1. Here are the factorials. So here I have 2, and 2 is factorial. 6 is 3 factorial. So I can see there is a factorial. So this is 3 factorial, and it is at 4. So that means it will be all here. We'll be saying times n minus 1 factorial. Okay. Hello? Can you see this? Okay. This is going to be our n derivative formula, right? And we can do some small adjustments, but this is going to be everything you need. This is going to be our n derivative formula, hey? So it'll be just like that. Yn will be what? Negative 1. So there we have it. Make sure you put that. So here I'll say negative 1 to the power of n minus 1. So you'd say yes, negative, and then you'd put your a to the n. Since this is a negative power, it goes, so it'll be a to the. So yes, here you have put a to the n. Remember to put now your ax plus b, but it is now to the power of positive n. Here you still have your n minus 1 tutorials. Anyway, what is this? Nth derivative of what? Here. So you have your n derivative and you'll be fine. Let's do the fourth case. It was for your n derivative for log. The last one now. Let's see how we get n derivative. The concept will never change. You are going to differentiate, then make up a, you are going to depending on what you are getting as you are stated. So, what am I going to say? Let's differentiate here. I differentiate this y is negative whatever. It's not hard. You drop this power, reduce it by 1, then you differentiate what's on the inside. So this is going to be y is equal to y1. I mean, it's negative 1, ax plus b to the negative 2. But since this is not just an x, you then multiply by the derivative of the inside. Derivative of ax is a. So you can say that your y1 is equal to negative a multiplying ax plus b all squared. Then now we can get y2. What does it? Drop the power, negative 2a. Reduce it by 1. A, by the way, this is to the negative 2. Wow, I didn't wrong. So you drop that negative 2, it becomes 2a. Then it is now ax plus b. This is now to the negative 3. Okay? And this is another one. Then you multiply by what? By a. So you can now say that y2 is equal to 2a cubed, then ax plus b to the negative 3. Can you understand this? You now have the second derivative. We're trying to see if there is a trend. Then you can follow y3. It is going to be negative 3 times this becomes negative 6. A cubed, then it is ax plus b. Then, okay, you have dropped down the power. It's now to the negative 4. By the power of the inside, by the derivative of the inside. Derivative of ax is a. That's what you do. Then you're going to have your y3 being equal to. So here, what are you doing? Here, what we are going to have is what? Negative 6a to the 4. And this is ax plus b. This is going to be what we have. And it is to the negative 4. So now we need to find a general formula for the nth derivative. Yn. It is equal to what? What is it equal to? We first see, do we have the sign changing? We can differentiate times like we've done. Y1 is negative. Y2 is positive. Y3 is negative, so it has a b. So this is our Y3. So you can see that the signs are alternating. It will be negative 1. Then we can go to Y2. We'll see that Y2 is positive. So that means that this is going to be positive. Then, so since second one is positive, it will be negative 1 to the power of n. Then you can see from Y2 to Y3, we jumped again. From 2 to 6, so there's going to be a complement. So in here, you're going to have your factorial. And what will be happening in this factorial? You are going to see that 6 is 3 factorial. So at 3, that is where we have 3 factorial. So there's going to be n factorial. Then we have seen the factorial to come from 2 here to 6. That's a factorial. Then we have a to the 4 for y3. Y3 has a to the 4. So we're going to have a to the n plus 1. So here we're going to have it as now a to the n plus 1. Can we put it a to the power of n plus 1? Then here we have divide, just divide and put it. It'll be ax plus b to the power of negative of n plus 1. Okay? This is going to be it, and you'd be having your formula for the nth derivative. Who has a question here? For the 4 situations on nth derivative. Those are 4 situations. Can we use them to answer? Yes. Now let's just put one more thing and try to do some questions together. Let's talk about somebody called Leibniz. From Leibniz, what we get is the Leibniz theorem. Are we together? This is what we are going to get from Leibniz. From Leibniz, we are going to get what they call the Leibniz theorem. It was going to be easier had you known the binomial theorem, but we don't need it right now, at least for now. So what does the Leibniz theorem say? Because you can't tell me that you want to do Leibniz, but you don't know what it says. How? Leibniz says when you have 2 things multiplying and you want to find the nth derivative. So that is what it's saying. The nth derivative of 2 functions that are multiplying. This is going to be what? This is going to be, if you want for 2 functions, you're going to say for the first one you get the nth derivative, so it'll be un. Then for the second one you get the 0th plus So here, what will it be? Nth derivative and 0. Then here, nth derivative minus 1. Okay, 1 behind the nth derivative. This is v1. But here you'll be now saying, before you put that, you say n choose 1. Let's put here. I want you to see what happens here. Sorry. You have n choose 1. Remember to put n choose 1. Then you're going to have u to the n minus 1, 1 less than, then v is to the 1, plus n choose 2, u is to the n minus 2, v is to the 2, plus n choose 3, u is to the n minus 3. Derivative number. 3 behind n term. So we start from n and we go down. And how to get this one is, you need the formula for nth derivative. That's why we taught you that first. You need the formula for nth derivative. Then in the formula for nth derivative, you'll be now just putting n minus 1 wherever there is n. Then you now have the formula for the n minus 1 derivative. Then here you'll be finding v1, you differentiate the other. The second function has to be differentiated. So you're going to differentiate v, and you'd have your v1, then you'd get your v2 and stuff like that. Do you understand this? Do you understand, or did you see the formula? If you have seen the formula, type, say yes in the chat. Say yes. Say yes, guys, if you have seen what I'm saying. Say yes. Here's the Leibniz. Let's go ahead and let's apply it. Don't want to hear anyone struggling with this. No. First question. Find the nth derivative. Go to the form, we did it. Find the nth derivative. Go to the work, we did it. Find the nth derivative. Go to the work, we did it. Find the nth derivative. The work, we did it. We've done these 4. I don't need to do them. Just go check our working. Differentiate once, twice, 3 times. Find what is repeating, and then you have it. Okay, are you hearing me? Now, we have this. We know how to get nth derivative. You differentiate 1, 2, 3, because these 4 are in the cases I gave you. For cos, I gave you. For e to the ax, I gave you. Okay, here it's a little bit different. It's e to the ax plus b. Maybe let's go and do it. We want to find the derivative of this, where they said y is e to the ax plus b. It's the same thing. Y1 is equal to. You're going to have e to the ax plus b times. What happens here? Derivative of ax is a, derivative of b is nothing. So you end up just having a e to the ax plus b. And it keeps getting, and you end up having a to the n, e to the ax plus b, a to the n, e to the ax plus b. That's what you end up having as your yn. That's your nth derivative. And you know how to do when y is sine of ax plus b. Here you'd say what? Your yn, if you want. It would still come back as what? We saw that it would still have an a to the n, but now it is sine, because it was sine here, of ax plus b plus. Here you can put it, and just remember to put pi over 2. And you're done. Anyway, this is crazy, man. I'm sorry for that. This is the nth derivative. You'd be done. I didn't differentiate once, twice, three, but this is what you'd get to. Okay, look at this. This is going to be nth derivative. Nth derivative, is it hard? No, it's not. Now, let's see here. Find the nth derivative and then compare. You have been given y is sine to the power of 4x. Then you want to find the nth derivative of this. Now, we know how to find the nth derivative if I have sine of something, but it should not be o squared or o to the power of something. So that means I should be able to change to the 4 of x. Right, let's go ahead and let's not do the practical questions. They say they want nth derivative and they've told you that y is sine to the 4 of x. Now, if you want, I'm going to share with you a PDF where you can find these solutions. I'm going to send you snaps of these solutions for those that need them, where you can have the solutions and go through them. You understand? So make sure if you don't have them or whatever, talk to me and then I can help you with these so you can get to work. Now, what are we saying? Here we have been given a y is sine to the 4 of x. I just need to change it to be sine x and cos x, or sine x and or cos x. If I do that, I can find the nth derivative, because I would now just do what I was doing for sine. I differentiate, and that's what you're going to do. So anyway, let's change this. This is sine to the 4 of x. Now, there is something that you know about it. This you're going to see again in integration. Because, ladies and gentlemen, boys and girls, we do not integrate sine squared. You're going to do trig integrals very soon after this test. So you got to butcher this test and move on. When you do trig integrals, you are going to know, and I tell you right now, that you are never going to integrate a sine squared or a cos squared. No, you won't. You are going to change them into something, but it shouldn't have the sine squared. And how you are going to change it, you are going to use what they call half angle formula. Do you hear me? I hope everybody can hear me. So you're going to use what we call the half angle formula. In the half angle formula, this is where we are going to know how to change these things. Half angle formula, yes. What does it say? What is the half angle formula, and then how do you get it? So if you want to do the half angle formula, here's what it's going to say. Let me try to load them for you, the half angle, if I can, and show you. Give me a sec. Let me pause the screen and try to load the half angle formula for you. Here's, okay, let me put it. Look at it. Let me show you where this would have come from. We say that cos 2x, this is going to be equal to 1 minus 2 sine squared x. Can you see this? This comes from the double angle for cos. Anyway, cos 2x is this. When we are doing half angle, you'd now say, okay, this is what cos 2x is. 1 minus 2 sine squared x. And also know that cos 2x will be 2 cos squared x minus 1. Okay, so here is my two versions. I want to remove sine squared, so I use this one. That's how you remove it. So you're going to have, here you've said that, do with the pencil, cos 2x is 1 minus 2 sine squared x. So that's, remember this one. Make sine squared the formula, so I'll take it to the other side because it's negative. It will be 2 sine squared x. It will be 1 minus cos 2x. Now what do? You take 2 to the other side. You're going to have sine squared x is equal to half of 1, because 2 goes, it becomes half of 1 minus cos 2x. So that's what we're going to do here. Hello. Sometimes you may have to do it twice, by the way. So here you're going to change sine to the power of 4. It is what? Y will be equal to sine x all squared. This is sine to the power of 4. Sine squared all squared. Which is how I'm going to do this. You are going to say, what is sine squared? It is half 1 minus cos 2x. It's not one of the cases with derivative. So here you would have it being what? You would have it now being, since you have this squared, eh? Can you see that you have this squared? How do you square something, man? Let's start by squaring 1 over 1 half. It becomes 1 over 4. Now let's square this thing, 1 minus cos 2x. We want to square it. Huh? This bracket. So you distribute the power of 2. That's what we did. Now we are inside here. 1 minus cos 2x. Let's square it. When you are squaring 1 minus cos 2x, what happens? This is going to be, you square 1. This is how you square a number. Because here it was O squared. Maybe let me put that stage. It was O squared. This is equal to half squared times 1 minus cos 2x O squared. I hope now you people can see here. Which is equal to half squared is 1 squared, that's 1 over 2 squared, that's 4. Then multiplying 1 minus cos 2x O squared. What do? You square the first term 1. You multiply them together, negative cos 2x. Then you double the answer, so you multiply them together and double the answer. So that will be minus 2 cos. So what would you have here? It will be 1 minus cos 2x is negative cos 2x times 2 is negative 2 cos 2x. Then plus this squared, cos 2x whole squared is going to be cos squared 2x. Okay, it's now positive. So here we'll end up having 1 over 4, 1 minus 2 cos 2x plus cos. Okay? Here it will be plus what? Let's deal with this cos squared 2x here. Let's deal with it. Plus, let's deal with this cos squared 2x. We know what it is. We know what cos 2x is. Okay? I mean cos squared x is. We don't want cos squared. We come from here. Cos 2x is 2 cos squared x minus 1. Right? Now let's find cos. Come from sine squared x to go to a 2x. You can see that you double here. It is cos 2x from sine squared. It's the same here. Cos 2x will now be 2 cos squared minus 1. You now take it. Cos 2x plus 1 is equal to cos x. Then we're going to take what do I do? Remove it. Half. But when you say half, double that angle. It will be now cos 4x plus 1. Because for cos squared x, it was half cos 2x. Where is it? It was half cos 2x plus 1 for cos squared x. For cos squared 2x, it's half cos 4x plus 1. There is no longer a squared. What a good thing here. 1 over 4 remains outside. 1 is 2 cos 2x plus half cos 4x plus half. Which will actually now become 1 over 4 multiplying 1. Then let's say 1 over 4 times 1 becomes 1 over 4. Right? Sorry for that. Okay? Then cos 4x plus 1 times 1, 1 over 2 times 4, 8. This is what we now have. And we could have it as saying 1 over 4 plus 1 over 8. Punch it in the calculator. Open 1 over 4, close, plus open 1 over 8, close. Is equal to, then you say second function. Then you press the button which says A, B over C to change to an improper fraction. t half cos 2x plus 1 nth derivative of this. Is this hard? No, it's not hard. Let's find the nth derivative of this. We don't even have to calculate. Yn is going to be, what do we do here? When you're doing nth derivative, let me tell you right now, when you're doing nth derivative, constants disappear, because we know that when we just differentiate once, this thing will go. Okay, so what we actually have is, let's first write to say what we actually had. We actually had y being equal to 1 over 8, okay, cos, even if I leave it like that, maybe let's just get nth derivative, man. We don't have to wait. Nth derivative, we saw that if I have y is equal to cos ax plus b, my nth derivative was what? What was my nth derivative? Yn was a to the n cos ax plus b plus n pi over 2. So a is what? The number before x. You hear me? So here, what will I now do? This is a number which is adding or subtracting. It's going to disappear. A number which multiplies never goes anywhere. So I still have negative half. Then I do my nth derivative. What's the derivative of cos 2x? 2 to the n cos 2x plus n pi over 2. I hope you saw that. I hope you know that. It comes back, but it now has n pi over 2. But then the number before x, you come and put it as a to the n. Plus, let's do for 1 over 8. Let's see. 1 over 8, it comes back. Then what do? You bring this back. But before you bring it back, the number before x, make it a what? A 4 to the n. So then 4 to the n. Then it's now by, what do you say? Cos 4x plus n pi over 2. This is going to be your final solution. Okay, cos is not, I'm not writing it right. It's cos of these two, 2x plus n pi. Then here it's cos of 4x plus here, like this. 4x plus n pi over 2 together inside one bracket. This is going to be your nth derivative. You see? Yes. Because you did the 4 cases. The 4 cases, if you know them, you can find for this. Sine ax plus this. Go and do this one. It's the same thing. We just did it. Let me just confirm. Sine x plus cos ax, which is a bit weird. Let's get our nth derivative. Sine ax plus cos ax. What are we going to do? We can easily get the nth derivative here. What is it? Nth derivative y to the n is going to be equal to. What happens here? You take this number which is before x, it is a to the n. Then you bring this back. It will be sine of ax, but it is now plus n pi over 2. Then here what you have? Plus. This is going to be a to the n, then cos of ax plus n pi over 2. Because this will come back, but it now has n pi over 2. Now what do we do here? We're just going to continue. We can simplify this to get a nicer thing, eh? What we can do is we can bring out a to the n. You now have the nth term just being a to the n, then you're going to have your other things, okay? Sine of sine of what? Ax plus n pi over 2. And a to the n, this one is still out, so it's just plus. Then you say cos of ax plus n pi over 2. Now, what are we going to have here? What are we going to have? Remember, this is our y to the n. Can you all see that? Now, what we can come and do here is to make our work easier for ourselves. Maybe we want to have it in terms of one variable only. So I can keep going and I can show what I'm going to do. In terms of one variable only. If I want it to be in terms of sine only or in terms of tan only, I'm going to square then square it if I want it to be like that. So what I'll do is I'll then say y to the n is going to be a to the n. Then I'll square this whole thing to say sine of ax plus n pi over 2 plus cos of ax plus n pi over 2. And what we are going to do is we're going to come outside, then square it, raised to the power of half. Then we go outside everything. Okay? That we have squared, and we are going to, so we square it, then we raise it to the power half. Okay, so we have squared it. Let's square it. You'll be having, I'm just doing this to get the nth derivative in terms of one guy. But you can, if you're stuck, leave it here. This is still the nth derivative. Now, the nth derivative in terms of one guy for this one, what would you now do? You would have, this is equal to, you have a to the n outside. Now you're going to square this thing. We know how to do when things are adding. You square the first thing, so this now becomes sine squared of ax plus n pi over 2. Plus, you multiply them together, then you double. So it'll be 2, then you put the 2 of them. Isn't it? It is going to be what? 2 sine of what? Ax plus n pi over 2. Okay? And cos ax plus n pi over 2. Here now, what you're going to do is you then add the square of the last thing, which is cos squared ax plus n pi over 2. Now what we are going to do is we have cos squared and we have sine squared. Now what you do know is that, remember that after everything there is still a power half. Here what we are going to say, we remember it's raised to the power half. Now, but what you should know is an identity which said sine squared x plus cos squared x is equal to 1. So here, this cos squared whatever plus this sine squared, we can have them. And they'll give us what? 1. So you now have y to the n is equal to actually a to the n. Then 1 plus 2 sine ax. So here it will be ax plus here n pi over 2. This is all to the power of half. Now let's finish this. What are we going to have? Y to the n is going to be equal to a to the n 1 plus. Now let's do here the last thing. Expand. We're almost done. You'd now say 2, then if you expand sine whatever, for sine comes, then cos comes. Okay? It's like you're opening it up. Okay? So what will happen? It becomes 2 sine ax, okay, cos n pi over 2. Then here you say that this is 2 because this 2 is just outside. We are opening sine. Remember, sine of a plus b is equal to, I'll take you through this when we have time. Sine a cos b. So here you'd say what? This is going to be plus cos A sine B. So here you'd say, what am I going to have? This is going to be plus, I'm showing you we're trying to remove these guys to simplify it. Oh, I'll take you back. This is a to the n. 1 plus 2 is going to multiply. This is going to be sine. Here it was sine of ax plus n pi over 2. So it's going to be sine ax cos n pi over 2 plus here you'd now write cos ax sine n pi over 2. Do you see it? Now, what are you going to do here? We now have sine n pi over 2 and cos n. All we need to do now is to get rid of, hello? We now want to get rid of this over 2 and make it just a pi. Once I have it like that, I will be able to know what to put. And I'll be done. This is going to be the very last stage. Can you see the stages which I've done up to now? What have we done? We differentiated. First, for if they give you for here, there's no need to even differentiate because you now know the nth derivative. You put the nth derivative, then they just want you to now combine. So what you're going to do is you have put it like this, and then you square, then square root, because you are trying to get sine squared plus cos squared is equal to 1. When you square and square root, you distribute the square, whilst the square root is outside. You're going to distribute the square. Then when you distribute it, you're going to simplify whilst the square root is outside. That's when you're going to get this sine squared and this cos squared, and they'll be just combining to give you 1. Then you remain with 2 sine ax plus n pi over 2. Now, when you remain with this one, after combining them, these two to give you 1, then what you're going to do is now change this sine ax plus n pi over 2. Here, what actually would have happened is, by the way, let me put it and make sure everybody can see. I can come inside here. When I had where did I do the double angle formula for you guys? It was sine ax plus n pi over 2. Let me find it. Funny. Okay, let me do it on this stage here. Let me teach you on this stage. If I have an angle, let's say sine of 30 minus 60, I'm just giving an example. This can become the same as sine of 60 minus 120. Okay? What can you do? You can come and double these individual things, and you should still get the same answer. Try it around and tell me if you're going to get the same answer. That would be what you should do. It should, if you double them, try it and tell me. If I come here and I want to remove this n pi over 2. We're almost done. We're simplifying. When you get here, again, you are now having you have removed sine squared plus cos squared is 1. You now have 1. You can double him and double him. Maybe let me do it before I do this last two stages. I will have my yn being a to the n 1 plus 2 sine. Inside you double. This becomes 2ax plus n pi. The answer should not change. And this is still O to the power half. Try it like what I told you. Try it to say, what is sine of 60 minus 30? Is it going to be the same as sine of 120 minus 60? If it's the same, then you know it's correct. You can double them both. Now what would happen is yn now becomes a to the n. We are finishing it up. Isn't this is O raised to the power of half? Now we are finishing it up because there's something we know. Let's expand like we had done. We have 1 plus. Let's just expand, because when I expand, I will be able to evaluate. Don't be scared. Sine is sine A plus sine A cos B plus cos A sine B. This topic, by the way, you are taught before you start your EMAT 201. It's called prerequisite knowledge. Because some of you will be looking at me and saying, how can you be just using things? How do you expect me to know? I'm going to take you through the things you need to know, especially going into integration. They are very, very useful. You need them. So in here, you're going to have 2 sine of, remember we made it, 2 is outside. Let's do the addition. It'll be sine 2ax cos n pi plus cos 2ax sine n pi. All multiplied by 2, then raise the power half. You'd now have it as yn is a to the n 1 plus here. What do we now have? 2 sine, 2 times this, it becomes 2 sine 2ax cos n pi plus 2 cos 2ax sine n pi. And this is all to the power of half. Now, what you must know, let's put it now. Edward, that sine of any pi, sine of 180, sine of whatever when we are doing for pi, anytime we add pi, this should give us 0. Any whole number for pi. So here I would get 0. And then cos of pi, you can punch in the calculator to say, what is cos of 180? Let me punch. What is cos of 180? Where's my calculator? Somebody please punch for me. Cos of 180. It helps you. I would say cos 180 degrees. You get -1. So that means here, cos n pi, I can say it will be cos pi times n. Stuff like that. So I would be cos n pi, this gives me like a -1. Right? Anytime I'm dealing with cos of a pi, it's -1. So these will be related to -1. So I'm going to have a -1 here. Then here I'm going to have a sine n pi, sine 180 is always 0. So if I'm to simplify this and put the last thing, I would know that when I am doing for the nth derivative yn, I would have it as a to the n, then inside is 1 plus, here 2 sine 2ax multiplying cos n. Since we are doing for yn, you would say it will be -1 to the power of n. Then plus here it will be 2 cos 2ax. Then sine n pi will become 0. So here we have it. And what would it now be if I put it like this and I've gone through? What would it be? This is all to the power of half. And I should be able to simplify it, right? What would it be? Remember that this was 0. You multiply by 0. This times 0 is 0. So here it will end up being 0. And it is the power of half. So we can now put our final solution to say nth derivative will be a to the n 1, then plus, or you can say 1 plus, you now say minus 1 to the power of n, and this is 2 what? Sine ax. Was it a 2 sine 2x here? 2 sine 2x. You would have it as your sine 2ax. And this is going to be plus 0. So you'd have your nth derivative something like this. This is going to be it, and you have your solution. Okay? This is going to be it. Do I have another question on this nth derivative? Fraction. For fraction, you're going to need to do partial fractions. To be nth derivative for this fraction, you're going to have to do partial fractions, and when you do fractions, you are going to have two fractions, 1 over something, 1 plus 1 over something. Then we can find their nth derivative, because that fraction, if it's 1 x plus 3, that means we now have x plus 3 to the negative 1. And that's case number 4. We know how to get nth derivative for something like that. Like, what would you do? We saw that, and when I had ax plus b to the negative 1, what was my nth derivative here? X plus b to the negative 1. It was, you have it negative 1 to the power of n. Then what else did you have? You had a again, a to the power of n. What else did you have? You now had n factorial over this one, which is now ax plus b to the power of n. So it is a to the n, negative 1 to the n, then n factorial over ax plus b to the n. This is what you had. So you do it the same for this one. Okay? You do the same for this one. Your nth derivative, it will still come out the same. The a is 1, so the a is 1. That's the only thing that is going to change. You'd still have the rest being the same. Anyway, you can go ahead and let's do it. X to the power 4, y is x to the power 4 over x minus 1, x minus 2. So what a simple question here. Y is equal to x to the power 4 over x minus 1 multiplying x minus 2. What you're going to do, partial fractions. Now you can say, okay, this is going to be the same as what? You can say x to the power 4, let's start with partial fractions, all over x minus 1 multiplying x minus 2. Partial fractions is when you are separating the denominator. So when I do partial fractions, I'm trying to separate denominators. And since these are two linear factors, I'll have a over the first one, x minus 1, plus b over the second one, x minus 2. B is just a fictitious number, and a, you have to find them. It's an arbitrary number. You have to find that number. So now let's find it. What do you do in the next stage for partial fractions? You're going to rewrite this one on the left, x to the 4 over x minus 1 multiplying x minus 2. The top didn't matter, okay, in this. You're going to have the same denominator, x minus 1 multiplying x minus 2. You bring it, okay? That's the same denominator, okay? It is the common denominator of these two. It's this one, which is on the other side. Now, what you're going to do is you're just going to say x minus 1 here for a. You'd say x minus 1 into this denominator. It cancels, you remain with x minus 2. That's what will multiply a. So you have a multiplying x minus 2 plus b. B is over x minus 2. So it cancels with x minus 2. And you'd have b multiplying x minus 1. Now, what do you do here? You are going to say, what is this going to be? X to the 4. Here, when you're like this, you can simplify if you want. You don't even have to simplify. Once you have written this statement, you can look at these fractions and you say that these two fractions are equal. And they have exactly the same denominators. That means the top must also be exactly the same. X to the 4 is going to be equal to a multiplying x minus 2 plus b multiplying x minus 1. x to the 4 is going, that means the top has to be equal, right? So we can say it is going to be equal to a times x. This is anything. You're going to say a. If you want to expand, it's up to you. Ax minus 2a plus bx minus b. Then you can compare coefficients if you want. That's one way to do it. To compare coefficients. To say, comparing coefficients, yes. Let's say coefficients of x. We're comparing the coefficients of x. What is before x on the left? There is nothing within x on the left, so we say 0 is equal to. What are the things that are before left on the right? It's a and b, so it is a plus b. So here we'll get a plus b equal to 0. Right? It would mean that negative b is equal to a. Then we can now say coefficients of, okay, or constants. When we have done the coefficients, okay. Now we are doing the constants. What do we have for constants? On this side we have no number, so we say 0 is equal to. What do we have here on this other side? Negative 2a minus b, so it will be equal to negative 2a minus b. Then you're now going to say let a be negative b, or if you want you can say let negative b equal to a. So you can now have 0 is equal to negative 2a minus b becomes a positive a. Okay, so this becomes 0 is equal to you're already finding them as zeros. Okay, let's do another method. Since here we don't have many things on the left, this method is better when I have many things on the left. Let me do another one, because I'll get a0 b0, which should not happen. The other way to do it is to say both of them should work either. Here we are now having the other way. You are going to choose a value of x which makes each of them 0. So I'll say let x be equal to 2. I will know that this will become 0. So I'll have 2 to the power 4 is equal to a multiplying 2 minus 2 plus b multiplying 2 minus 1. I will now have 2 to the power of 4 is 16. This is equal to a by 0, which is 0, plus b by 2 minus 1 is 1 times b is just b. So I can say 16 is equal to b. And I can have now, we say x to the 4 is equal to a multiplying x minus 2 plus b multiplying 2 minus b multiplying x minus 1. Now you're going to choose another one. You say let x be equal to 1, so that this denominator becomes 0. You now have 1 to the power 4 is equal to a multiplying 1 minus 2 plus b multiplying 1 minus 1, which is going to be 1 equal to 1 minus 2, that's negative 1 of a, plus b times 0. 1 is equal to negative 1a. Then we divide by negative 1. We say 1 over, okay, sorry. We now say 1 over negative 1 is equal to a. Negative 1 is equal to a. So we can now rewrite this fraction to say x to the power 4 over x minus 2, x minus 1. This is going to be equal to a over x minus 1, b over x minus 2. A is negative 1, so it's equal to negative of 1 over x minus 1, plus what's your b? Is it actually 16, I guess? So you'd have 16, huh? So it'll be 16 over x minus 2. Now, what are we going to have here? We're going to say now, that is our what? Remember, we had been given as the y. So we can now say y is equal to negative of 1 over x minus 1 plus 16 over x minus 2. Now we go for it. Easy peasy lemon squeezy. Find the m derivative here, Captain. So you say y is equal to negative of x minus 1 to the power of negative 1 plus 16 x minus 2 to the power of negative 1. What are we going to do now? What are we going to do? Sorry, it's not the power, it's the power negative one at all. What are we going to do now? We are going to do our nth derivative. Let's find yn. What is it going to be equal to? We start with this part. Hello, ladies and gentlemen, we start with this part. What will happen? What will happen? We know that it will be minus 1 to the power of, was it n plus 1 or n minus 1? You can have it as to the power of, here we would have, let's find it. Let's go to the nth term of this. Here. Nth term was when you have y, b, a, x plus b to the negative 1. Nth term is what? Negative 1 to the n factorial. Yes. It has 4 things, okay? So let me rewrite it. It is going to be what? Yn will be equal to negative 1 to the n. Yes. N factorial. Yes. Then this a to the n. A to the n. Yes. All over ax plus b. And ax plus b in the bottom is to the power of n plus 1. Not n plus 1, okay. To the power n plus 1. So here I would come and say, I remember that now. This is negative 1. Let me say negative 1 to the n for this one here. It is negative 1 to the n factorial. Then what is a? The a is 1 times 1 to the n all over. Here, there's a negative, by the way. There's a negative outside because there was a negative here. All over, what is it? X minus 1. This is to the power of what? N plus 1. Plus negative 1 to the power of n factorial. Then what number is between? There is a 16, by the way. 16 is just outside. So it's negative 1 to the power of n factorial. Then x, there is just a 1 before it, so it's 1 to the n, all over x minus 2 to the power of n plus 1. This is going to be equal to, we are done. We are done. You can factor out some things, okay? Like negative 1 to the n. So negative 1 to the n times n factorial. And here what would we have? Negative 1 over x minus 1 to the power of n plus 1. Then here we say plus 16 all over. Here is 16 all over because 1 to the power of n is still 1. Any number, 1 to the power of anything is still 1. And it's all over x minus 2 to the power of n plus 1. This is going to be what we have, and it's your final solution, and you are done. Is this hard? All right. Here's your solution and you're done. For those that needed to see it. This is to do the nth term. So if you need revision on nth term, just know those 4 cases and try out these questions. Know those 4 cases and try out these questions. Then let's see the other one. The other one is now saying, use Leibniz to find this. Then find the nth derivative of that. Use Leibniz to find nth derivative of this, and then use Leibniz to find nth derivative of that. Let's go ahead and let's use Leibniz. We want to now do the Leibniz theorem, and we want to see how far we can go with it. So I'm going, if you want me to redo, you can do, you can go move back the video and rewatch. That's the good part about it. You can move back and rewatch anything you need. But for Leibniz, we have number 4a, then we have number 4b. Okay, let's do Leibniz. Number 4a and number 4b. Okay, so what is number 4a saying? Using Leibniz, find the nth derivative of x log x. Then using Leibniz, find the nth derivative of the second one. So these are the two things that we are left with. Using Leibniz, wow, what is happening? We have x log x. So let's put that. Let's say that we have y be equal to x log x. Let's find the nth using the Leibniz. So what you're going to do for Leibniz, this is just easy. For Leibniz, you are going to, if the situation is not given to you already, you will create one, but you need a situation where you have two things multiplying, right? When you have two things multiplying, then one is u, one is v. For one, we are going to differentiate to find the nth term. Remember, your Leibniz just says that if you want the nth term of two things multiplying, then you are going to say nth term of the first times the 0th derivative of this, which is the original function. Then you now say plus n minus 1 term, okay, the nth derivative rather, not nth term, the nth derivative, multiplying v1, which is the first derivative, plus un minus 2 multiplying v2. And you keep going, okay, until the v is over, is finished with, or until you get back where you started. So for this v, what is my v? What am I going to choose for v? Something which will differentiate and finish. I'll use x. Okay, this is already like stuff you're going to see in integration by parts. But anyway, since you haven't done it, this is v and this is u. So anyway, let's differentiate. So I can say my v is equal to x, which means that my v1 is equal to 1. Which means that my v2, you can now say the derivative v prime is equal to 0 for k greater than or equal to 2. Meaning when I get to the second derivative, okay, v prime is equal to 0, or v prime k. You can see v of k is equal to 0 for k greater than or equal to, which means when I get to the second derivative going forward, my velocity will now be, my v will now be 0. So that means I'm only going to get to v1, which means I'm only ending here. I'm doing Leibniz, it's ending here. So that means I only need un and I only need un minus 1. So you can say your u is equal to log x. What is the nth derivative of this? What is the nth derivative of log x? You go back to the cases, we did them. The nth derivative of log x, you gotta remember them. So maybe at the year we should just practice the table in case, because when you are putting it in situations like this, you don't even need to have to work it out. You need to just use the table. In the table, you see that for our table. Let's put the cases which you guys will have. If you have y is equal to ax plus b to the power of negative 1, then you must know that your nth derivative is going to be negative 1 to the n factorial, a to the n over ax plus b is now ax plus b to the n plus 1. Excuse me. Then what about if I have the other one? If I have y is equal to log of ax plus b, then I'm going to have my nth derivative being equal to negative 1 is now to the n minus 1. Okay, negative 1 is now to the n minus 1. Then you are going to have, instead of n factorial, you also have n minus 1 factorial. Okay, so you still have n minus 1 factorial. All right, then this is for log. Everything is n minus 1, but a is still to the n, and in the bottom you still put ax plus b, and x plus b is still to the what? N plus, no, it's to the n, and you're done. So you'll be having a to the n, then it is to the n, x plus b to the n. This is going to be the end. Negative 1 is not to the n, it is to the n in ax plus b. Then in the other one, it is to the negative 1. Okay, put these. Then now you're going to put the situation number 3. If y is equal to, well, for the other two, we know them. For the other two, we don't even need to do ax sine of ax plus b or cos whatever. It'll be, you have your yn now. It is going to be equal to a to the n. Then what are you going to have now? Open bracket, sine ax. Okay, you're going to say a to the n, then sine, open bracket, ax plus b plus n pi over 2. Now, this is for sine x or for cos x. If it was cos here, it would come back as cos here. I can put it if you want. Ax plus b, which means that the nth derivative is just a to the n cos here ax plus b plus n pi over 2. Anyway, we now have the last one being when y is e to the ax. Can say e to the ax plus b even. You're going to have your yn being a to the n e to the ax plus b. So yes, this is the situation which we have. Now let's go back to our question. Log x, what is it going to be? -1. It is to the n plus 1. Okay? It is to the n minus 1, not n plus 1. Then you have what? N minus 1 factorial. Then if it was log ax, you now have a to the n, but it is here 1 to the n, because that's log of 1x, all divided by x. Here, because you had it as log x, so what is it? It is all going to be divided by whatever is inside log, you raise it to the power of n. So this becomes what? -1 to the n minus 1 times n minus 1 factorial all over x to the n. Is it not? Now that we have it like this, we can now start to deal with this. Do you see? Now we can start to move with our Leibniz now. Because what? I have my un. It is -1 to the n minus 1 times n minus 1 factorial all over x to the n. So what will be now un minus 1? Because I also need un minus 1. My v is ending at 1. Un minus 1, this is going to be wherever there is n, we are putting n minus 1. So it is -1 to the n minus 1, then minus 1. Then multiplying n minus 1, then minus 1. And this is going to be factorial. All over x to the n minus 1, which is going to be -1 to the power of -1 minus 1, that n minus 2. Then -1 minus 1, it will be multiplying n minus 2 factorial all over x. So x to the n minus 1. Now what are we going to do? We put in our, and we are done. We put in our Leibniz formula, we put them things down, and we are done. Okay? uv, nth derivative, is equal to, what is it? un v0 plus n choose 1 un minus 1 v1, which is going to be un is this times v0, which is the original v, which is times x. You're just multiplying by x. Then what are you going to have? So it's going to be -1 to the power of n minus 1 This is multiplying n minus 1. We can put n minus 1 factorial over x to the n. This is multiplying x. This is the first one. Plus n choose 1. Then what are you going to have? N choose 1. Then you're going to have this other one. Now, I want you to know that n choose 1 is like a constant in our case here. So we would have what? We'll just have it as un minus 1 times v1. So it's going to be minus 1 to the power of n minus 2. Here it'll be over x to the n minus 1 times again here v1. v1 is just a 1, so times 1. Then we're going to simplify. And you are done. You can now try to simplify here. Okay? Just by simplifying, everything else becomes done. So if you want, we can finish it up, the working. You still have the same values. N minus 1 factorial all over here. X to the n times x here is like you can say the bottom minus the power on the top, because they have the same power. This is the power of 1. You can have it as x to the n minus 1. You can put it like this. Plus, because we believe that n will be bigger than 1, so we subtract this minus. Then you can have minus 1 to the n minus 2 multiplying n minus 2 factorial all over x to the n minus 1. And we can see that all of them are over x to the n minus 1, which means we can factor x to the n minus 1 outside. Okay, and we can find out what the solution would become. But that's going to be the end. You can leave it here, and it's still fine. You've done enough. That's good. This is Leibniz. You need to do this other question, which is a little bit long, but it's good, it's nice, it's beautiful. The last question, which is saying, let's go back to that last question and let's do it. On Leibniz, at least if we're good at Leibniz and nth derivative. Here, y is a cos log x plus a sin log x. Y is equal to a cos log x plus a sin log x. This is my y. Now I want to find the Leibniz. But Leibniz is things are multiplying, because we know the formula. And these things are clearly not multiplying. So I'm going to need to change them to have them multiply. Then I'm going to apply Leibniz. So it's quite a longish. It's quite long. But that's the nature of some tutorial questions. We all know that some tutorial questions can be this long. So here, what does it say? What do I have? I have y being equal to a cos log x plus a sin log x. What you're going to do first is you're going to differentiate. And you're going to differentiate twice. And you're going to have what you want. We're going to differentiate, and you should see what will happen here. I'm going to try and differentiate to generate a certain equation, because I have one function inside another here. I don't have them multiply. They are not. But I'm going to have to create where they multiply. So, what do I do here? A cos log x plus a sin log x. Differentiate once. y1 is going to be equal to. A is just a constant. Differentiate cos, you get negative sine of log x times the derivative of log x is 1 over x. Isn't it? plus a stays outside. Differentiate sign, you get cos of log x times the derivative of the inside of log x, which is 1 over x. You now have your y1 being equal to negative a sine log x all over x plus a cos log x all over. What you'd have now, it is O, right? So it's OX. What you'd have now is your Y1. But what we're going to do is the right hand side. You can have your Y1 being equal to 1 over X. We'll have here negative A sine log X plus A cos. So here, what would it be? It'll be a cos log x. This goes to the other side. You'd have xy1. This is equal to negative. xy1 will be equal to negative sine log x. So here it will be a cos log x. Now, what do you do here when I have it like this? I don't have it in the form I want. I'm going to differentiate it again. I'm going to differentiate it again. People, I'm going